Okay, in this video we look at how to get an exponential function notation out of some information about points. Here I've given them in function form, but you might have a table, you might have something else. First thing I was looking to try to see if that c value is easy. That's the y-intercept. That would be 0 in and then c out, but 0, no, neither are 0. So now I've got to look at some other information. Exponential functions are ratios from point to point, meaning they're a constant multiplier because of the base, like f of x equals, say, 2 to the x. That's numbers are multiplied by 2. When you put 1 in, you get 2 out. But when you put 2 in, you get 4. 3 in, you get 8. And 4, 16. See, they're multiplied the output by 2 all the time, right? So I need to find what that 2 is, or what is that a in this case. One way to do that is to get rid of is look at the ratios. So I start out with this. I start out with c a to the x, and I create a ratio out of 2 of them because I got 2 points. You'll notice that no matter what the c is, they all divide out, right? But the numerator a to the x is going to be different than the denominator a to the x given these 2 points if I'm using this information. Meaning, this says if I put negative 1 in for x, and this says put negative 2 in for x. Now, I'm going to create a ratio with those information, so I'm going to put the larger x on top and the smaller x on bottom. That's how I do it so that it's easy, comes out easy. Meaning, if I put 2 in here, I get a to the second power. I'm ignoring the c because they cancel, right? A to the second power. If I put negative 1 in there, a to the minus 1, and that's going to be the one down here, a to the minus 1. The reason why I do that is because I see that there's a negative number and I'd like to move it up. It becomes a squared times a to the first, which is a cubed. See? Now I have a cubed. Well, that doesn't help me just by itself, right? Because I want to know what a is. But I have to find outputs to be able to find a. Because this ratio will also show me an output, right? The top one was a function f of x. It was c to the ax. I put in 2 for x, right? Well, if I put in 2 for x, what should my y output be? 18. So I'm going to put, this is also 18 though, right, as a y value. 2 in, this mess becomes 18. Alright, well, what if I put negative 1 in? It becomes 2/3. Now, I have that this, 18 divided by 2/3, is equal to this whole mess, which comes all the way out to be a cubed. So now I can say that a cubed is equal to 18 over 2/3. Now I'll either take the calculator or I'll do a little flip multiply. Take 18 and divide it by 2/3, which is really 18 times 3 halves, right? Because I have to do this, 3 halves there, and 3 halves. So 18 divided by 2 is 9, times 3 is 27. So that mess is 27. Cubic root both sides to get rid of the cube. That means a is 3. So my base is a 3. So far I have f of x equals 3 to the x, but I have that c out front, c times 3 to the x. I need to find out the c still. Well, I've got 2 points. This is the easy part. Pick one of the 2 points. Probably this one's easier. So 2 in, 18 out again, right? So if I put 2 into my function, which looks like this, I'm supposed to get 18 out. So that is supposed to be 18. So I'm going to erase it and put 18. That's 18 equals c times 9. Divide both sides by 9. 2 equals c. Okay, so now we've got my a and my c. I go up here, replace that right there, right, with a 2, and there's my function. That is a exponential with a base of 3. Going to be the y-intercept of 2, right? So it just doubles all the exponential base 3. So let's look at the graph. Here's the graph. So there's my 0, 2, right? And what were my 2 values again? Negative 1 2/3 and 2/18. Let's see if it works. Negative 1 2/3, -1 2/3 and 2 18. Yep, and that's what it looks like. Goes through 0 2 1 we didn't know was 6, but that's what it is, 1 6, and that's what the graph looks like going through those 2 points. Okay, let's continue on here. Look at some linear growth versus exponential growth. So this is very similar information. Here I'm giving inputs of 0 1 2 3 and these outputs of 2 5 8 11. Now linear growth increases by a fixed amount for each value x increases. Okay? So look from here to here. From 0 to 1, this increases by 3, right? It goes up by 3. Then from here to here, 1 to 2, it goes up again by 3. So this is what the slope is, right? The slope is the change of the y's over the changes of the x's. So we have 3 to 1, my slope, the changes of the y's over the x's. So that's a slope, into the equation of a line. And then what we have is our y-intercept over here of 0 2, right? 0 in, 2 out. So there's the equation of this linear function right there. Slope, y equals mx plus b. Slope, y-intercept. So it goes up from y value to y value, from x value to x value, by 3. Okay? Versus an exponential, exponential increases by a factor, by a multiplier. So look at this. As I go by 1, don't look at the difference, not up by 4, but it goes times by 3. It's a multiplier by 3, right? And then from 1 to 2, see now look at it goes up by 12. It doesn't stay constant like this increase stays constant. It's a multiplier. It times by 3. Times by 3. So that's the difference in how you can tell whether something's linear, because it's constant increase, so an addition, whereas an exponential function is a constant factor, a constant multiplier. From one x value, from each unit, it gets multiplied by a certain value. So this is multiplied by 3. So this one would be y equals 3 to the x. And then this has so that's my base, because it's a constant multiplier. And then this is my y-intercept again. 0 in, 2 out. So notice, there we go. Same problem what we were doing. So to review quickly, if you're given something like that, this is the information you need. Linear growth goes up by a fixed amount, m, they call it, for slope, right? For each unit increase in x. So for each 1 it goes up here, it goes up by a fixed amount for your y's. Exponential growth increases by a factor, a, so a multiplier, for each unit in x. So you want to look at from one unit to the next, what's the factor it goes up into? And that's the difference between exponential and linear functions.